Dear students, we are studying the chapter chemical bonding, and in the chapter chemical bonding we will study about VSEPR theory. So in the chapter chemical bonding there is a very important theory which is called as VSEPR theory. So let us know what do the alphabets VSEPR stand for. V stands for valence, S stands for shell, E stands for electron, P stands for pair, and R stands for repulsion. So basically we are studying valence, shell, electron, pair, repulsion theory. What is the advantage of studying this theory? Yes, tell me why we should study VSEPR theory? Because it can help us to know the geometry or the shapes of molecules. Okay, so we want to know about the geometry or shapes of molecules, hence we want to study about valence, shell, electron, pair, repulsion theory. Each word in this theory is very important. Please understand that in molecules there is a central atom, and that central atom is surrounded by electron pairs. Let us take the example of BeCl2. So in case of BeCl2, if we draw, then we can write like this. So which is the central atom? Tell me. In this case, Be is the central atom, okay, surrounded by chlorine, and one line or one bond represents here one electron pair. So tell me how many electron pairs are around beryllium? Yes, correct. There are 2 electron pairs around beryllium. Good. Let us take another example, that is CH4, also called as methane. In case of methane, can you guess which is the central atom? Correct. The central atom is carbon, and carbon is surrounded by 4 hydrogen atoms, as we can guess from the Lewis dot structure. So let us try to make the Lewis dot structure of methane. So it will be carbon with 4 valence electrons, isn't it? And each hydrogen with 1 electron. So you will have this as the electron pair. Okay, so you have already learned about Lewis dot structures. So in valence, shell, electron pair repulsion theory, you have to remember that there is a central atom which is surrounded by other atoms, and the central atom has electron pairs. So valence shell of the central atom has electron pairs. In this case, carbon is the central atom. Tell me how many electron pairs are there? There are 4 electron pairs, 1, 2, 3 and 4. So, these are the electron pairs around carbon. Here the central atom is beryllium and it has got 2 electron pairs with chlorine. Let us take another example. Another example I am going to take is of water. Yes, can you tell me the formula? Yes, it is H2O, oxygen, isn't it? So, oxygen atomic number 8, electronic configuration will be 2,6, and hydrogen atomic number 1, electronic configuration 1. So, which is the central atom here? Please tell. Yes, the central atom is oxygen and the oxygen has got 1, 2, 3, 4, 5, 6 electron pairs, and we have to put 2 hydrogens. So, this is one hydrogen and this is another hydrogen. So, the central atom here is, tell me, it is oxygen. How many electron pairs are there around oxygen? There are 4 pairs, 1, 2, 3 and 4. Now, out of these 4 pairs, these 2 are different. Are they undergoing bonding? No, they are not undergoing bonding. Hence, these are the non-bonded electron pairs, also called as lone pairs, and the other ones, these which I have marked with a different color, these are called as the bond pairs. So, please understand that in valence shell electron pair repulsion theory, we have to identify the central atom. We should be able to make the Lewis structure, and when we make the Lewis structure, we should be able to identify the lone pairs and the bond pairs. I am sure you are able to make this much structures of atoms which are bonded to form the molecules. Now, let us understand the basic points of valence shell electron pair repulsion theory. We have to remember that the central atom is surrounded by electron pairs. The central atom is surrounded by electron pairs. And what are the 2 types of electron pairs? The electron pairs can be lone pairs or the electron pairs can be bond pairs. The electron pairs around the central atom can be lone pairs or they can be bond pairs. Now, what is the significance of the term repulsion here? What is the charge of electron pairs? Can you tell? Or the charge of any electron? Yes, correct. The charge of any electron is negative. So, the electron pairs, they will repel each other. Why they will repel each other? Because all the electron pairs are negatively charged, isn't it? So, the electron pairs which are negatively charged, they will repel each other. Now what we have to remember, that there are two types of electron pairs, the lone pairs and the bond pairs. So is the repulsion between lone pair and bond pair going to be same, or is the repulsion between lone pair and bond pair going to be different? What you have to remember, that the lone pair repulsion will be more than lone pair bond pair repulsion. Please note this, please remember, because it is going to be very useful for us to study the geometry or shapes of molecules. So the lone pair repulsion will be greater than lone pair bond pair repulsion, which will be greater than bond pair repulsion. Okay. So let us just summarize what we have learned till now. We are learning the valence shell electron pair repulsion theory. In the molecules, we identify the central atom. The central atom is surrounded by electron pairs. The electron pairs of the central atom are in the valence shell, hence the name valence shell electron pair. What are the two types of electron pairs? Can you tell me? Yes, correct. The two types of electron pairs are lone pair and bond pair. When we know how to make the Lewis structure, we can decide and we can know that the electron pair is lone pair or bond pair. So we have to remember that the lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. And this is the basis of valence shell electron pair repulsion theory, and this will help us to know the geometry and the shapes of molecules. I am sure children you have understood well, and now we shall proceed further. So now we will take certain examples, and with the help of examples we will study the geometry of molecules. Okay. So let us take the first example of type AB2. Now in case of AB2, the central atom is A, okay, and it is bonded with B. Okay. So central atom is A and it is bonded with B. Now this is one bond pair, this is another bond pair. So there are two bond pairs, and how these two bond pairs will try to arrange themselves? They will try to arrange themselves so that they are as far apart as possible. Hence they will be at what angle? Can you tell? Yes, correct. They will be at an angle of 180 degree. This angle is going to be 180 degree, and this shape will be linear. What is the example for this? The example for this is BeCl2, beryllium chlorides. Now, in case of beryllium chloride, tell me which is the central atom? The central atom is beryllium, okay, and it is bonded to 2 chlorine atoms, okay. So, one bond pair here, another bond pair here, and the angle is 180 degree. So, the chlorine this try to remain as far apart as possible and the shape will be linear. So, this is the first example we have studied, AB2 type. This is linear shape. Example is BeCl2, beryllium as the central atom, chlorine on either side. The 2 bond pairs, they try to remain as far apart as possible. Hence, the angle is 180 degree and the shape is linear. Now, see children, this is the ball and stick model. Can you see? Now, this is the ball and stick model. In the center is beryllium. This is one chlorine. This is another chlorine and this is the bond pair, and you can see what is the shape of this molecule. The shape of this molecule is linear. I am sure you have understood the concept. So, now we will study further. The next type of molecule that we will study is AB3 type. So, I am writing here AB3. The next type of molecule that we are going to study is AB3. So, let us decide the central atom. The central atom here is A, and A is surrounded by how many B atoms? A is surrounded and bonded to 3 B atoms, and in this case the B atoms, they will try to stay as far apart as possible. Now, in this case, can you tell me what will be the bond angle? Okay, so this total is going to be 360 degree. So, we have got 3 B atoms. So, when we see the angles, it will be 360 degree divided by 3. That means this will be 120 degree. So, each bond angle is going to be 120 degree, and if I connect the B, the shape is going to be trigonal planar. So, AB3, the bond pairs, they try to remain as far apart as possible. Hence, the bond angle will be 120 degree and the shape will be trigonal planar. Now, let us take an example. The example is boron trifluoride BF3. Okay. So, tell me which is the central atom here. The central atom here is B, boron. So, it is bonded to 3 F atoms, F, F, F. So, there are 3 electron pairs. These 3 electron pairs tend to stay as far apart as possible. Hence, each bond angle will be 180 20 degree, okay, and the shape will be trigonal planar. So I am going to show you the ball and stick model for BF3. So see this, and I am sure you will understand better. This is the central atom, boron. The red balls, they are the fluorine atoms, F atoms. So boron central atom, 3 F atoms, and the bond pairs, so as to minimize repulsions, they tend to stay as far apart as possible. Hence the bond angle will be 120 degree and the shape will be trigonal planar. So I am sure children you have understood the concept well by now, and we will now study further and we will see the next shape which we have to take up as per valence shell electron pair repulsion theory. Okay. So we will take the next shape for valence shell electron pair repulsion theory. So the next will be AB4, isn't it? We started with AB2, the next molecule is AB3, and now we are going to study AB4. So which is the central atom? Tell me. Yes, correct. The central atom is A, isn't it? And it is bonded to 4 B atoms. It is bonded to 4 B atoms. Now these B atoms will try to stay as far apart as possible. Okay. Now there are two possibilities. The B atoms may arrange in a planar shape, but then the bond angle is going to be 90 degree. However, AB4 molecule takes up a 3-dimensional shape, and the AB4 molecule is arranged in a tetrahedral manner, A in the center and B atoms are arranged in a tetrahedral manner. Okay, please see this shape now. So this is the tetrahedral shape of AB4. What is the advantage of having a tetrahedral shape? That it gets the bond angle 109 degrees 28 minutes. The bond angle in a 3D shape is 109 degrees 28 minutes, and hence the bond pairs tend to stay as far apart as possible. So what is the example? Can you guess the example of AB4 molecule? Yes, correct. It is methane or CH4. Now in case of methane or CH4, which is the central atom? The central atom is carbon, and carbon is surrounded by how many hydrogen atoms? Carbon is surrounded by 1, 2, 3, 4 hydrogen atoms. And how are these 4 hydrogen atoms arranged? These 4 hydrogen atoms are arranged such that methane has got a tetrahedral shape, okay, and the bond angle is 109 degrees 28 minutes. The bond angle is 109 degrees 28 minutes. So when we join this, it becomes like a tetrahedron shape, and the bond angle is 109 degrees 28 minutes. So let me show you the ball and stick model for methane. This is the ball and stick model for methane. Now in the center is carbon. You can see clearly this black ball represents carbon. These four red balls, they represent hydrogen. This is a tetrahedral shape. You can see it's a three-dimensional shape, and this is a tetrahedral shape of methane molecule. So students, we have studied three molecules or three shapes of molecules till now: AB2 linear, AB3 trigonal planar, and AB4 tetrahedron. Let us study further about the next type of molecular geometry, and the next type of molecular geometry is AB5. So what is the central atom in case of AB5? Correct? The central atom is A, and other atoms around A, they are 5 in number, and it is AB5. So we have B, we have B, B, B and B. Very interesting. In this case, 3 B atoms, they are arranged in the same plane, and these 3 B atoms, they are called as equatorial. So we have equatorial, we have equatorial B, and we have the third equatorial B. Also there are 2 B atoms, one on top and the other at bottom, and this is called axial and this is called axial. Okay. So in this case we have the trigonal here, okay, and this bond angle is 120 degree, and we have axial, and can you guess what will be the bond angle between axial and equatorial? It will be 90 degree, because we want to minimize the repulsion. What is the example of AB5? The example of AB5 is PCl5. Now in case of PCl5, P or phosphorus is the central atom. It is surrounded by 3 chlorine atoms, and the 3 chlorine atoms, they are arranged such that the bond angle is 120 degree, okay, such that the bond angle is 120 degree. These are called as equatorial chlorines, and one chlorine is above this plane, another chlorine is below this plane. These are called as the axial chlorines. Okay. So let us see the bond angles. Here the bond angle is 90 degree. Okay. So what is this shape called? This shape is called as trigonal bipyramidal. This shape is called as trigonal bipyramidal, and in a trigonal bipyramidal shape we have got 3 atoms in one plane and we have got 2 atoms, one above the plane and another below the plane. Okay. So we will have a shape where we have a central atom, one atom above, another atom below, axial like an axis, and 3 atoms equatorial. Let me show you the shape. Okay. So once we have this shape, this is the planar, and we can have in the planar one atom above, one atom below and 3 atoms at the equatorial. So this is PCl5. Next we come to the shape of or the geometry of AB6. Next we come to the shape or geometry of AB6. Now in case of AB6, please tell which is the central atom. Yes, the central atom is A and it is surrounded by how many B atoms? It is surrounded by 6 B atoms. So first B atom, second B atom, third B atom, fourth B atom, fifth B atom and sixth B atom. You can see now this is the shape of almost like a square. This is the shape of the square and one B atom above and another B atom below, and this is called as the octahedral shape. In this molecule all bond angles and all bond lengths are same, and all bond angles and all the bond angles they measure 90 degree. What is the example? The example is SF6. In case of SF6, sulfur is the central atom, okay, and the central atom is surrounded by fluorine. 4 fluorine are on the same plane, as you can see. 4 fluorine are on the same plane, so I am joining the 4 fluorine to sulfur and the bond angle is here 90 degree. One sulfur is above, another sulfur is below, and here also the bond angle is 90 degree. So this is the shape of SF6, octahedral shape. Now let me show you the octahedral shape. This is the octahedral shape. The yellow atom is sulfur. There are 4 fluorine in one plane. They are at 90 degree to each other. One fluorine above, another fluorine below, and these are also at an angle of 90 degree, and this shape is called as the octahedral shape. So let us just revise the valence shell electron pair repulsion theory that we have discussed today. First of all, AB2 linear, next is AB3 trigonal planar, next is AB4 tetrahedral, next is AB5 trigonal bipyramidal, and the last shape that we have studied today is AB6, which is called as octahedral. So these are the basic geometry that the molecules they possess. I hope you have understood the topic well. Thank you.